everyone, hope you're doing good. So, in my previous videos, you have seen under the topic properties of quadrilaterals and polygons, our first subtopic that was classification of polygons. Now, under the same topic, we are going to study our second subtopic that is angle sum property of a polygon. Now, we are all familiar with this topic, right? Angle sum property, because we have studied this topic under quadrilaterals also, triangles also, isn't it? Now, we are going to study the same topic under polygons. Before going to the topic in deep, first let's understand this angle sum property of a polygon in a more easier way by performing an activity or an experiment. You can also do this at home with a sheet of paper and a pencil. So yes, you can see three polygons here, right? What are those? First one is a pentagon, second one hexagon, and third one is a heptagon. You know why the names are kept like that? Why? Because in the first figure, it is a five-sided polygon, and a five-sided polygon is called pentagon, isn't it? In case of hexagon, six-sided, hence hexagon. There, the third one, seven-sided polygon, so hence the name heptagon. Now, you may be wondering that why have I drawn these lines inside the polygon, isn't it? Before going into this experiment, first you have to know the fact or you have to have that prerequisite knowledge of the angle sum property of a triangle. I will tell you this later why you have to have it. So what is the angle sum property of a triangle? 180 degrees. Yes. Now, yes, we were talking about the lines inside the polygon, right? So let's go to the first one. How many so with these lines, what are these lines representing inside the polygons? Yes, they are representing the triangles. So basically in a polygon, through these lines joining from one vertex to another vertex, we can form triangles. So in case of a pentagon, how many triangles have I formed? 3. Hexagon, 4. And heptagon, 5. Now, you can observe that pentagon has 5 sides. How many triangles have we constructed? 3. In case of hexagon, 6 sides. How many triangles has been formed? 4. In case of heptagon, 7 sides. How many triangles have been formed? 5. So, from this we can get to know that a polygon having n sides, the number of triangles is less than 2 of it, or 2 less than the number of sides. For example, in case of pentagon, I'll explain you again. There are 5 sides in a pentagon here. How many triangles? 3. So basically 2 less than the number of sides, isn't it? Same in case of hexagon. 6 sides. 6 minus 2, 4. So 4 triangles. Similarly in case of heptagon, 7 sides. 7 minus 2, 5. So the number of triangles in a polygon is given by 2 less than the number of sides of the polygon. You can try with any of the polygons. It is the same concept. So basically from this experiment, we can deduce the equation of sum of the interior angles of a polygon by the product of the angle sum property of the triangle. What is that? 180 degrees into 2 less than the number of sides. Like this. See, sum of the interior angles of a polygon is given by n minus 2. That is 2 less the number of sides, but n is the number of sides into 180 degree. The product of the angle sum property of a triangle. That's why I said you in the beginning that you need to know the angle sum property of a triangle here. So 180 degrees into n minus 2, where n is the number of sides of the polygon. I told you why the equation n minus 2. From where did it come? From where the number of triangles is given by 2 less than the number of sides. So n minus 2 into 180 degrees will give you the sum of the interior angles of a polygon of the interiors of a polygon. So angle sum property of a polygon is given by this formula. This will help us find the sum of the interior angles of any polygon when the number of sides are given. Now, this formula can work for any polygons you want. Okay, where you know the number of sides. But what happens in case of a regular polygon? The formula which we wrote just now, n minus 2 into 180 degree, can work for any polygon, irregular, convex, any polygon, only when you know the sides of it. But in case of a regular polygon, how do we find out the measure of each interior angle? It is given by this formula. Sum of the interior angles of a polygon divided by number of sides of the polygon. So in a regular polygon, keep this in your mind, it's important. In a regular polygon, the measure of each interior angle in a regular polygon is given by the formula sum of the interior angles of a polygon divided by number of sides of the polygon. Whereas the angle sum property or sum of the interior angles of any polygon, it can be any polygon, regular, irregular, convex, concave, any polygon, is given by n minus 2 into 180 degrees. Please study this formula properly. Don't get confused. Yes, we can also use this property to find the missing angles in a polygon when the measures of all other angles are given. Using this statement, we can, this property, we can find the missing angles in any polygon when the measures of all other angles are given. We'll solve some sums based on this. You will get an idea about it. Yes. Now let's solve some examples. Your example number 1. What is the sum of the interior angles in the given polygons? So your first polygon is a decagon. Now what is a decagon? A polygon which has 10 sides is called a decagon. Okay, a 10-sided polygon is called a decagon. So your first question is, what is the sum of the interior angles in the given polygon? Now decagon. How do you find the sum of the interior angles? We have cited the formula just now, right? N minus 2 into 180. So firstly, calculate the number of sides. How many sides are there? 10. So substitute in the given formula, that's it. 10 minus 2 into 180, which is 8 into 180 is equal to 1440 degrees. Same in the case of octagon. You can solve it on your own. How many sides are there? 8. So substitute in the formula, you will get the answer. Yes. So let's go to example number 2 now. What is the measure of one of the exterior angles of a regular hexagon? Now, just now I had taught you the formula that in order to find in a regular polygon, the measure of each interior angle is given by sum of the interior angles of a polygon divided by number of equal sides of the polygon. Now, what is the sum of the angles of a hexagon? 360 degree. Very good. What are the number of sides? 6. So just substitute in the formula. Number of equal sides in a regular hexagon is given by 6. Sum of the exterior angles of a polygon is given by 360 degree. We all know this, right? Sum of the exterior angles of a polygon is 360 degree. So using the formula, divide 360 degree by 6, you will get 60 degrees. So the measure of one of the exterior angles of a regular hexagon can be given by 6, is equal to 60 degrees. You can use this formula to any of the regular polygons. Okay. So say if it's a regular quadrilateral, then what would be number of equal sides? 4. Then you will divide 360 by 4. You will get 90 degrees. Yes, because 360 divided by 4 is 4 ones are 4 nines are. So 90 degrees. It's the same for any of the regular polygons. Okay, you can use this formula for any of the regular polygons. Yes. Now, the third example. Find the measure of the angle x in each of the given polygon. So which polygon is this? What is the name of it? As it has 7 sides, it is a heptagon. Now we can see that the number of some of the angles have been given in this polygon, and one angle is unknown, that is x, and we need to find out that unknown angle. So how can we find out this? Yes, using the angle sum property of the polygons we can find out this. So this is the solution. So yes, see, applying the angle sum property we use the same formula, n minus 2 into 180. So what is your n here? 7. 7 minus 2 into 180 is equal to, what is 7 minus 2? 5. So 5 into 180 is 900. Now bring your x this side. So 900 minus the sum of the other angles, right? So I had told you that property, right? We can use this angle sum property in order to find the measure of the missing angle in the polygon when all the other measures of the angles have been given. So we are using the same property here. We found out the total angle. What is the total? 900 degrees. That 900, that total we subtracted from the sum of the other angles, right? What are those other angles? 109 plus 117 plus 146 plus 156 plus 133 plus 78 will give you 900 minus 739, which is equal to 161 degrees. So your unknown angle x is equal to 161 degrees. So your first step is to find out the total angle. What is your total angle? Using the angle sum property, that is n minus 2 into 180, we find out the total angle. Then we subtract the total angle from the sum of the other given or known measures of the angles. Right? That's what we did here. We know the other measures. We added that and subtracted from the total one. Then we get our x value or our unknown angle. Similarly, we do it with octagon. 8 sides. So hence the name octagon. Here also we have an unknown angle. How do you do it? Same, using the angle sum property. Here n will be 8. So 8 minus 2 is 6. 6 into 180 is equal to 1080. Same thing again. Subtract the total from the sum of the other known angles or given angles. You can do it for other polygons also. Take an example and do it, so it will be a practice for you. So 1080 minus 954 is equal to 126 degrees, which is your unknown angle x. Yes, let's do some practice questions now. Yeah, our first question. Angela wants to make a sail in the shape of an equilateral triangle. We all know what is an equilateral triangle, right? A triangle having equal number of equal sides, which measure in which the measures are equal of the sides is called as equilateral triangle. Now, what will be the sum of the angles of the sail? Now, we all know that the angle. What is the angle sum property of a triangle? In the beginning, also I asked the same question. In order to know this chapter, you need to know the concept of the angle sum property of a triangle. What is the angle sum property of a triangle? 180 degrees. So what will be sum of the angles of the sail? Definitely 180 degrees. How? Because each angle in an equilateral triangle measures 60 degrees. So 60 plus 60 plus 60 will give you 180 degrees, which is your sum of the all the angles of the sail. Okay. Let's go to the next question. What is the measure of the missing angle x in the polygons? Again, just now we solved the same type of question, right? So solving the missing angle. Yes. So now your question is there are some of the angles have been given here. If you want for your reference, you can draw a polygon. So it's how many number of sides is there? 6. So basically it's a hexagon. So for your reference, if you want, you can draw it. Otherwise, it is not needed here. They have not asked you to draw. They have just asked you to find out the measure of the missing angle. Again the same concept. Find out the number of sides. So there are 6 sides. How? How did you find out the number of sides? Because there are 6 angles here. See, 121, 83, 147, 162, x and 88. So how many angles are there? 6 angles. Hence 6 sides. The number of angles will give you the number of sides. So this is how you find out the number of sides. If you can't find out like this, better, it is not wrong to draw a polygon from given number of angles, so that by counting the sides you can find the number of sides. Okay, if you don't know how to find like this without drawing a polygon, okay, it just takes few seconds. So from this given number of angles, we understood the number of sides is equal to 6. Applying the angle sum property, now it's easy because we have done 2 types of sum like this. So 6 minus 2, again n minus 2 into 180 degrees, which will give you 4 into 180, 720. Your total angle subtracted by the sum of the known angles will give you an x value, that is your known angle 119 degrees. Same in case of this second question, B part. Again, how many angles have been given here? Again, 6 angles. So number of sides is 6. So find out the total. Subtract the sum of the other angles, you will get the value. Similarly, in case of C, in what does the C part tell us? How many angles are there? 7 angles. So hence number of sides is 7. Okay. Do the addition properly. You may go wrong while doing the addition. Don't do those mistakes. Similarly, in case of D, how many angles are there? 5 angles. So number of sides are 5. So whenever you find out a missing angle while the other angles are given, the only thing you do is use the angle sum property. Find out the total angle by using the formula n minus 2 into 180, where your n is your sides. Then subtract the total from the sum of the known angles. You will get your x value or unknown angle value. Practice few more questions if you don't have clarity about it. Yes, let's move to the third question. The measure of 4 of the exterior angles of a pentagon are 47 degrees, 62 degrees, 84 degrees and 104 degrees. What is the measure of the fifth angle? Now we all know that a pentagon has how many exterior angles? 5. In that, 4 exterior angles have been given to you. You need to find out the fifth angle. Now first and foremost, you people tell me, what is the sum of the exterior angles of a polygon generally? What is the sum of the exterior angles of a polygon? Yes, 360 degrees. So now we know the total angle. What is the total angle? 360 degrees. So we are going to subtract that 360 degrees, which is the sum of the exterior angles of a polygon. Here it's a pentagon, minus the sum of the given angles. See, first take the sum of the given exterior angles. What are the given exterior angles there? 47, 62, 84 and 104. Take the sum of it. What is the sum? 297, and subtract it from the total. That's it. What's the total? You know. What is the sum of the exterior angles of a polygon? 360 degrees. So 360 degrees, which is your total angle, minus the sum of the given angles in the question. 360 degree minus 297 will give you your unknown angle, that is the 63 degrees. So 63 degrees is your fifth angle. Understood? Always remember, you need to keep this point in your mind. This whenever they ask you to find out the unknown exterior angle of a polygon, whether it can be any polygon, always the sum of the exterior angles of a polygon will be 360 degrees. You just need to do this. The sum of the exterior angles of polygon is 360 degrees minus the sum of the given angles in the question, given exterior angles in the question. That is what we did here also. We took the sum of the given exterior angles and subtracted from the total. That is your 360 degrees, which is the sum of the exterior angles of a polygon. Always remember this point. From this, we can find out the unknown angle. Here is a measure of the fifth angle. So your fifth angle is equal to 63 degrees. You can solve more questions based on this for your practice. Thank you everyone. Hope you have understood the topic for today. See you in the next video.